the first lesson videos of this class, we discussed, among other things, the type of compaction equipment. To do compaction, we apply energies. And there are 4 ways to apply the energy. First, the impact, so the sharp blow to the lift thickness, or we use the pressure, basically the static weight of the equipment, such as roller, or vibrations with the equipment, so that we have the soil occupy the void in the soil, the solid part occupy the void and the air. And the last one is kneading. Basically, we manipulate and rearrange the soil so that the oil, the void, the air get out and the soil occupy, and we increase the desired dry density of the soil. And depends on the type of materials and then also the equipment, we can select equipment for different type of material, and that also discussed in the first lesson video of this class. So now, with that background, we want to determine what should be the productions for the roller that play a role at the compaction. So that the topic we talk in this video, that roller production. And how to determine the roller production? It measured by the volume per hour. So in the volume, it measured by the compacted cubic yard, and production per hour. And the equation equal to 16.3 times the width of the compacted areas times the average roller speed times the lift thickness L, and then times the efficiency, and divide by the number of passes, N, or number of passes. So what is that about? Let me define each of the parameter in there. W is stand for compacted width per pass. Per pass, and it have to be, to apply that equation, measure in terms of feet. And then we have S, average roller speed, and measure it mile per hour. And then L, the compacted lift thickness, and measure in inch. Keep that in mind. So in the previous problem 1, we use the feet to do conversion, but use this equation as the they already consider the unit conversion, and you can see the number here, 16.3. So already included with the unit conversion. So we don't worry about the unit conversion, to put exactly the unit that we discussed and described in this. So thickness measured in inch, and N stand for the number of roller passes required to meet the desired density. And before we go to problem 2, we want to show you the number of passes for the roller. So here see the typical effect of number of passes. So the relationship between the number of passes and the desired dry density of the soil after compaction. As you can see, for the first 10 passes, the more you increase the number of passes, the densities increase significantly. But after 10, then it about to level off. After 50, the increase of the desired dry density not increase so much. So you can see it doesn't mean that we increase the compactive effort that you can achieve the desired dry density if you improve the number of passes, like go to 1,000 times, etc. It will increase, but not so much. So as you can see, after 50 times, how many enough for the number of passes depends on a few things: the type of soil, cohesive or gravel or sand, and then it depends on the combination of the machine, the compaction equipment, and the time of soil. Something we talk about the compaction equipment selection. But basically here you can see 50 passes not increase so much for the desired dry density for the soil. And normally we will specify that in here, that is the number of passes. Of course, if we increase the number of passes any in the denominator, it will reduce the roller productions. So that let's apply that in problem 2 here. A cell propeller tamping food compactor, so you see a roller, used to compact a field being constructed of clay material. The field tests have shown that the required density can be achieved with 4 passes. So it ends with the speed of the roller, so that is at 3 miles per hour. The compacted lift will have a thickness 6 inches. The compacted width of the machine, so which is W in that equation, 7 feet. 1 band cubic yard equal to 2.83 compacted cubic yard. So that one is basically we learned in lesson 1, that is shrinkage factor. Scraper production estimated for the project, because that is the first scraper to excavate, to put the material on, and the roller compact the material. So that production rate for the scrappers that we discussed in lesson 4, 510 BCY per hour. The question is how many rollers will be required to maintain this production, so that whatever the material excavated from scraper, the roller, the compactor, can be accommodated to compact it so that it have a smooth operation. So basically no bottleneck either from the scraper or the roller. And they give us the efficiency in 50 minutes per hour. So let's do that one. First, we need to determine the production rate of the roller and compare that with the production rate of scraper, so that we can determine the number of roller required. So there are 2 steps in this problem. The first one, we need to determine the compacted using the equation above. We need to determine the compacted cubic yard per hour, and in this case for roller or compactor. And that equation we already have. First, the unit conversion number 16.3 here, as you can see, time the width here is 7 feet, time the average roller speed 3 miles per hour, time the lift thickness 6 inches, measured in inch, 6 inches, time efficiency 50 minutes per hour, so 50 divided by 60, divided by the number of passes, in this case 4. So from that we get the this equal to 428 compacted cubic yard, because the unit that have per hour. And because the production rate of the scraper is BCY per hour, so either you convert BCY to CCY or CCY to BCY. In this case, I convert the compacted cubic yard to band cubic yard. And how to do that? It equal to that from lesson 1, you have 28 divided by shrinkage factor, because 1 BCY equal to 0.83 CCY. So you get divided by that one, 0.83. And from that we have 516 BCY per hour. And when you have that production, we can compare and to determine the number of roller required. Number of roller required, and it equal to maintain production, they have to match Now bottleneck, something we did before. So as you can see here, scraper production divide by roller production. So from that we have scraper production 510 BCY per hour divide by 516 BCY per hour. So it's about 1 roller. So roller production a little bit more, but you see very close. So what does that mean? We only need 1 roller in this case. So that is the answer. Only 1 roller needs it.